Okay, now let's start with SAP HANA. Now the version which is available latest is SAP HANA SPS 12, Service Pack Stack 12. Okay, many of the people wondering what is SAP HANA. Now SAP is in the industry since last 17, 18, 20, 25, 30 years, since 70s I guess, but I'm associated in 2000, early 2000. So SAP is completely different from the regular databases so far. But SAP came up with the idea of in-memory database. So let's discuss what exactly the SAP HANA is. The term HANA, H-A-N-A, is a high performance analytical appliance which is an in-memory database. So you must have, I see there are so many BW guys, so they might have not known extensively about database. They will be, because BW hides the database behind the scenarios, but business objects, Anil might have known what exactly the database is. Database, you can see the collection of informations which is in a general terminology, which you can say, which will be stored in an organized way in tables, rows and columns. All right. So that is a general perception, general information we have about database. Now SAP HANA, which is a high performance, why we required high performance? Why we required another database in the market? We have like plenty. MS SQL Server we have Oracle, we have DB2, we have, like, you know, there are many databases available in the market right now. Why do we require a new one? Now, to answer this question, I wanted to take you to early stages of application development, early stages, maybe around 30, 40 years before, when just computer started, maybe it started to boom in Western world. There what happened, this database came up with RDBMS and relational database management, and what they did was they created front-end applications and they designed the database in the way to store the data from the front end and save the data in the back end. So mostly they were doing complete transaction storing. Like if you take a Walmart example, when you go to a Walmart, you buy plenty of things and your data will be loaded into your database. Like front end system scans it and the database takes the data and stores it. Now this was the scenario from the early days of data storing. Now 10 years, 15 years passed and the data is increasing, like adding up, you know, piling up, data is piling up. Maybe 15 years down the road, 20 years down the road, data became huge. Now these systems which were created, developed in a transactional perspective, they were only to add the data, I mean to say store the data inside the databases. They were not perfect enough to analyze the data in such a huge volumes and give you answers from that particular data. So now what happened? Then came the concept called OLAP. Initial days, which we were talking about, the data stores with traditional front end and back end is called online transactional processing, that is OLTP. Now, when there is a requirement arised where you wanted to analyze the data in such a way, you need to mine it properly and get the analytics out of that huge volumes of data and use that analytics to make a decision in a managerial positions or a CEO positions, or which affects for a business. That technology, that concept was developed later stages of OLTP, that is called OLAP. Maybe most of you already known BW candidates, they might know, and even BJ, Anil might have known this. But for Sangeeta and for Uma, probably they might have not even Samir, you guys not known of this information in the previous hand. You might have read somewhere, but this was the data storage concept. Now when this OLAP came into the picture and OLAP started, organizations started designing data warehouses with the help of star schemas. So what happened? Then they used to extract, transform and the load data with regular traditional third-party ETL tools, or in case of SAP, we have a SAP BW scenario, BW application. Using that, they develop a data warehousing scenario, and using that data warehousing scenario, they used to provide cubes. They used to develop cubes, and these cubes are available for reporting purposes, analytical purposes, where you can analyze the data in a multi-dimensional way and take decision accurately. So this was the scenario till early 2000s and late 2000s, you can say till 2009, 10, 8, 9, 10. So even after 15, 20 years of OLAPs and OLTPs, and there were huge projects transforming data between OLTPs and OLAPs, and loading the data, scheduling the data, batch jobs, and all the delta. So all this information passed, and the data became humongous, and it was in some organizations it became uncontrollable. Even the OLAP scenarios are not performing the way it's supposed to perform, and not able to analyze the data on the fly, because the need of the hour is you want answer in a seconds, not minutes. If I'm not wrong, business managers want answer in fraction of seconds. They want it yesterday, not today. So in this competitive world, there is a need arised into the market, and SAP, what I can say, SAP took it as a maybe challenge. Maybe they might be researching since last 10-15 years. I'm not completely sure about that, SAP, what they are doing, but in early 2011-12, they released a version. It's called SAP HANA in-memory database. Now, you might be wondering what exactly the in-memory database and how it helps to increase the performance of a query, and how you get the answers on the fly, and the real-time data, how you can able to analyze this. This is the future right now. There is no competitor in the world right now for the SAP HANA, as far as my knowledge goes. Oracle tried it with different technologies, Excelitics or something like that, but it's not quite as a SAP HANA, as I can say you that. Let's take a small example. Let's take a small example. Are you guys understanding what I'm trying to say here? If you have any queries, just shoot me, okay?
Okay.
Sangeeta, Uma, Samir.
Yeah, we're good, Santosh.
Okay. Now, yeah, okay. Now, let me give you a small example where you can even understand more, more about SAP HANA, why it is that much popular, and why it is giving you so much of performance while querying. Now let's assume we have a table. Table contains only 4 columns. Everybody know what is table, right? I don't need to tell you what exactly the table is.
Yeah.
Okay. Now this table contains only just 4 rows. Let's say we have customer column and product column, amount column, and quantity column. Everybody knows what exactly it is, right? When a customer goes and buy a product, then he has to, this is a unit amount and a quantity. This is the information storing into a table. This is very simple. And this table contains, let's say, 2 trillion rows. 2 trillion plus rows. Now this is a simple table. Only 4 columns, but in real-time scenarios you won't be seeing such a simple table. There may be like hundreds and thousands of columns, or number of columns will be there with trillions of rows. But I'm just taking, for sake of understanding, a small table which has only 4 columns with 2 trillion rows. In a regular traditional databases, MS SQL server, if we want to answer, okay, top 50 customers. So like business wanted to know give me top 50 customers, and I wanted to give them some bonus or maybe some rewards or some maybe discounts. So this is a small, what you can say, small question you might get queried. To answer this question in a traditional MS SQL server database, which is RDBMS, it takes minimum 3 to 4 hours to execute this query. Why it is required this much time, you will understand in the coming session. I will help you one by one. It required at least 3 to 4 hours to run, because it has to go through all 2 trillion rows one by one. It has to compute amount into quantity, and it has to go through each and every row, each and every column and compute, and it has to process all 2 trillion rows, and it has to sort in a descending order and try to get you top 50 customers and then present you. This is a process it will take inside, okay, one step at a time. Then you get the answer of top 50 customers. But the same answer, if you want it in HANA, okay, it takes 2 to 3 seconds. It takes only 2 to 3 seconds to execute this query. So there is a huge difference of performance between the traditional databases and SAP HANA. Why we have such difference? I'll give you the reasons. There are mainly 4 reasons you will get such a high performance in SAP HANA. In-memory database. Second one is columnar tables. Third one is massive processing. Data shrinking. Now these are the four main reasons why SAP HANA is giving such a huge performance comparative to MS SQL Server. Let's discuss these topics one by one and try to understand what exactly these topics are with small examples. Okay? Somebody just interact with me. I feel like I'm a radio.
Yeah, please continue, Santosh. We are hearing.
Okay, I don't want to be one-way communication, guys. So I just wanted you guys to interact with me. That's the reason I unmuted you guys to ask me few questions so that I can able to answer you. Maybe you might have read all this information, but it is my job to help you understand. Each and everybody should be on the same page. That is the reason I'm trying to give you this information. We'll discuss one reason, one topic at a time so that you can able to understand them.
Okay.
Santosh, you can go ahead. I mean, we also are understanding so that we are ensuring we are not missing out on anything. So
Okay.
that's good.
Okay. That's fantastic. I think Lenin just joined in. Can I quickly talk to him if you don't mind?
Yeah, that's okay. Let's go ahead.
Hi Lenin, can you please describe, can you please give me your little background about yourself so that I can able to understand you?
Yeah, I am Kadiravan Lenin, that's my full name. You can call me Kadiravan Lenin. So I have Oracle PLC good background, and I'm working on a product which already implements in memory. So,
Okay.
but I'm looking for more like switching technology to SAP HANA. So,
Okay,
so that's why I'm here.
that's fantastic.
Since everybody is just they're just opening up, I thought I'd just have an intro. This being my first session.
Okay, this is the first session to everybody. Okay, this is okay. I'm your instructor. My name is Santosh.
Hi,
And,
Santosh.
yeah. Okay, and I hope you understand what I'm trying to say right here. Okay.
Yeah,
You're following,
I could figure it. Yeah. So the first 15 minutes I missed out, but I could very well understand.
you will get this recording video from IntelliPad, so you can communicate with them and take it. Okay, later on.
Yeah, thank you so much. Thank you.
Okay, thank you. Okay, let's go into this topic one by one. Let's take a small example to each about each topic, and then we can discuss one by one. Okay, now let's discuss about in-memory database. Now, let's go back to the early stages of computing. What are the main components of a CPU for a computer? I can tell you the main component of the computer is CPU, RAM, and a disk.
Disk, yeah.
So these are the main components. I mean, there are plenty of components, but these are the main components of any computer. Let's talk about traditional Oracle or MS SQL Server database. Now, when you store the data in a traditional MS SQL Server, your data is stored here in a table. This is, let's say, 2 trillion rows table we have in our disk. When a query, let's say when a query, the same top 50 customer query, when it hits here, MS SQL Server, it has to take the request to the CPU, to the RAM, to the disk, and load the data into the RAM and process the data into CPU, and this has to go through until 2 trillion rows are computed, and the transfer of data between these devices is massive, and these devices communicate with a bus, okay, and reading of data from a disk is very time consuming process, because the data which is stored inside a disk in a table format, it's stored in a continuous memory location, and it has to go through all 2 trillion rows with each column and search for answer and try to process in processor and try to give you the result after computing everything and try to give you the result. So as we discuss here, that is out of 3 to 4 hours of time consuming, 90% of the time, 90% of time takes to execute query is to read, fetch, compute data from disk, and the remaining 10% is processing and presenting. This is what happens in a traditional MS SQL Server database, or any, in fact, for any databases. The data is stored in a disk. Now let's say we have a SAP HANA. Okay, SAP HANA, we have a processor, and we have a RAM. Now this 2 trillion rows data is stored here. Complete 2 trillion rows data stored here. So what happened means, when a query executes, when I try to fetch the query, the data doesn't require to go to the disk and try to read, fetch and put it in the RAM, because every time it has to bring all 2 trillion rows into the RAM and process with communication with the CPU. So we don't have this disk at all in the SAP HANA environment. So the time consuming between CPU and RAM is very high, and the RAM is very much, the data is very much close to the CPU with high massive parallel processing CPUs with number of cores of CPUs. That is the reason that the performance of a query reduces very drastically in the HANA. This is the one reason why we get performance, high performance out of the query. Okay, anybody has any questions on this?
No, Santosh.
Okay, let's discuss the second point, because HANA consists of like major four topics. all 4 topics combined together, you will get very high performance. So let's discuss the second topic. What is the second topic? It is column or table.
Santosh, I have a question. Sorry to
Please,
interrupt you.
please, please.
So, yeah, actually, like if you say, here you have taken 2 trillion rows, right? So in real time, there are many trillions of records, right?
Yes, yes.
So how is that the RAM is that much capable to carry like the whole that much data?
Okay, very good. You hold on this question till end of the session, because next 3 points which I am going to tell you, these 3 points will answer the questions, your question automatically.
Okay.
Okay, just hold on this, because I have to explain it anyway, right? So as far as this is concerned, you are clear, right, why the in-memory database is there?
Yeah,
Okay.
that is it.
Now, next we'll talk about columnar database, columnar tables. Now let's go back to the another similar example. Let's go back to the similar example of this row, this table, because I don't want to take a different approach. You might get confused, so I wanted to take it a similar example so that you will be easily understood. Now the similar table we have in a traditional MS SQL server or Oracle, traditional database. Now the data stores in a table, as you can say. Let's say C1, P1, amount 10, quantity 1, like that. It stores. Now in a traditional MS SQL server or any other database, the data stored in a disk we discuss here. How it is stored in a disk means it's stored in a continuous memory location. Now when you have rows, okay, when you have rows like this, the data stored in a disk as a continuous memory location, like C1, P1, 10, 1, C2, P2, 2, 1, like that. So the data stores in a continuous memory location as a file. Now when you query this for a top 50 customers, so what happened means it has to go and search customer, product, everything it has to go. All 2 trillion into 4 it has to do, and even it has to compute amount and quantity as a sales, and even that has to be calculated and searched. This is called, the storing of this is called row-based tables. The data is stored in a row. But in SAP HANA scenario, the same table, but look and feel of this table, it looks like a regular table when you see from the SAP HANA Studio, but inside the RAM, inside the memory location, it stores the data in a columnar way. Why it is stored in a columnar way, we'll discuss that. Similar, let's take similar rows, C1, P1, 10, 1, C2, P2, let's say 2 and 1. This in SAP HANA, okay, this, the data stored in a individual files. Every column stores in a individual file. C1, C2, P1, P2, 10, 2, 1, 1. So now the data stored in SAP HANA in a columnar way, columnar tables. So what is the use of storing the data in a columnar instead of row based means? As I said, SAP HANA, it is a high performance analytical appliance. This database is main purpose, the usage of this database is to do analytics at very high speed. It's a live data, you can do the analytics. To perform such high performance analytics, you require a technology behind the scenes which should support them. So it is not good to store the data in a traditional OLTP way, but it is completely high performance to analyze the data, reading the data from the tables. Okay. So when you read the top 50 customers from this table, SAP HANA table, now let's say to get the top 50 customers, what it required customer column, amount column and quantity column. It required only 3 columns. It doesn't want product column to be processed at all. So in this scenario, with SAP HANA, it directly take this file and compute. Each individual file is processed by each core of a CPU and then merge them together and present the data. Means it can ignore unwanted data to be processed. That is the meaning of columnar database, retrieving the data. Anybody has any doubts on that?
No, Santosh. It means in this case, suppose if you want to see top 50 customers, it will ignore directly the P1, P2. P1, P2 is not required.
Of course, in a real-time scenario, let's say we have 170 columns, right? And you wanted only 3 columns out of 170. So what is the wastage of processing 167 columns?
Right.
That is the beauty of the HANA. It ignores, because the data stores in a column, right? It can directly go and check for that column and try to compute there. That's it. It ignores. Here in the traditional row-based tables, it has to go through each individual memory location and try to figure out whether that is used in my query or not. If it is used, it has to compute, process. So that is what the processing takes place in a huge time taken process for MS SQL Server. But in regular SAP HANA, it will only select those columns. In my query, it doesn't require. Maybe in few queries, you don't even require many of the scenarios. Let's say in one of the major questions they ask you, give me year-end sales, right?
Right.
So what do you want? You want a year column and complete sales column. That's it. You ignore complete 168 columns there. So the process, it takes only 2 columns and try to compute and try and present it. So the combination of columnar database, columnar tables in the in-memory. Okay? These two concepts are making SAP HANA more powerful.
Right.
Okay.